Okay, means a microgrid either will behave as a load or will behave as a source in perspective of the main utility grid. So it can connect and disconnect from the grid to enable it to operate in both grid connected or islanded mode. Means if your microgrid is connected to main grid, then it is called grid connected mode. If your microgrid is disconnected from the main grid, it is called islanded mode. So what is a microgrid basically, that we will see in the architecture diagram. So before that, I will explain some this type of microgrid. So microgrid can be AC microgrid, DC microgrid, and hybrid AC DC microgrid. If you follow some books, there will be many definitions for microgrid like AC, DC, and hybrid. But what I found suitable is we can bifurcate this classification based on type of load. If your microgrid is having only AC loads, that microgrid we can call AC microgrid. If your microgrid having only DC loads, that microgrid we can call DC microgrid. If your microgrid is having both AC and DC loads, then we can call it a hybrid microgrid. Though there are many definitions in books, like sometimes they told if your generation facility is AC, then we can call AC microgrid. But what I found suitable is we can classify this based on the type of loads only. So this is the types of microgrid. Either we can have AC, DC, or hybrid, means both AC and DC. So there is a basic structure for the microgrid. We are having one power grid with us, and this power grid is connected to some multiple bus system through a point of interconnection. Point of interconnection is that point at which microgrid is connected to main utility grid. So I have one 5-bus system here. This system I connected to this power grid to a point of common coupling, and this bus system is having some loads, some residential loads, some small commercial loads, and to fulfill these loads, we should have some distributed energy resources here. What is meant by distributed energy resources? Distributed energy resources, DER, is just some small generation facility that can provide power irrespective to the condition of grid. Means whether your microgrid is connected to grid, whether it is not connected to grid, these DERs are having some capacity to fulfill the load demand. So what I considered here, one solar panel as 1 DG, one distributed generation as diesel, one diesel generator as DG, and one energy storage. Why energy storage needed here? Actually, load and generation in a microgrid are varying very much fast. So to cope up this thing, we need some energy storage device. For example, if your load is less, but your solar PV is generated higher amount of power, then that power you can store in the energy storage system, ESS we call it. And in case of less power generation, your solar panel will provide power to the load along with the energy storage. So means if there is any unbalance between the generation and load demand, this energy storage will play the role there. So can we call this system a microgrid now? No. The reason is that just by integrating the DGs into a system, the DERs into the system and load, we cannot call this system a microgrid until we connected a controller there. There should be one proper control mechanism to control the DERs and the load there, and also the point of interconnection. So for that, I'm having one centralized control here. I will explain by centralized I'm calling. So this centralized control is collecting data from all of these devices, and then it is generating some command to these particular utilities to work properly. So this centralized controller is connected to all the generating facility, all the loads through some localized controller. I will explain the purpose of localized controller and centralized controller. Okay. So now what are the components of microgrid? So microgrid is having controller. I told this is the most important thing of microgrid. Controller, then distributed generator DG, and distributed energy resources DERs are same only. Then storage device, load, and some additional element. So we will see one by one. So controller can be centralized, can be decentralized, or can be distributed. Centralized controller means what? Your microgrid is having one centralized controller. That particular controller will collect data from all the DERs and load, and it will process that data and generate the reference signal for the utility. Decentralized means what? There will not be any centralized controller. Every DER, every load has its own particular controller. It will collect the data, instantaneously process the data, and regenerate the command for that particular utility. Distributed means what? We are having localized controller also and centralized controller also. Some of the work will be done by localized and some of the work will be by centralized controller. And distributed generators are of two types. One is dispatchable, one is non-dispatchable. What is mean by dispatchable? Like diesel and this hydrogen fuel cell. These are called dispatchable source. Why these are called dispatchable? Because we can regulate their power output according to the load demand. So what are the non-dispatchable sources? These are solar, wind, or small hydro. Why these are called non-dispatchable? Because we cannot regulate their power output completely as per the load demand. See, solar PV is having some restriction based on the weather forecasting, based on the solar irradiance. We have to keep the things like we cannot increase the power demand more than some particular limit. So these particular DERs are called non-dispatchable. Storage are also of many types like flywheel storage, pump storage, then supercapacitors, then battery bank. Battery bank and pump storage are very popular, but these days supercapacitor is also very popular because of its capability to handle the transient in power. I think you all people are aware about these terms because you are in some third year, final year like that. So what load we are having? Load can be critical load or non-critical load. So what is the critical load? Critical means some hospital supplies, some railway supplies. These all called critical load. Means we cannot curtail this load in any situation. Non-critical means what? Some irrigation, some local household like this. What additional elements are required in microgrids? Additional means intelligent circuit breaker. There should be one intelligent circuit breaker at the point of interconnection. Means at the point where your microgrid is connected to the main grid. There one intelligent circuit breaker should be there, which can observe the condition of the main grid, means utility grid, as well as your microgrid. And its purpose is to synchronize the both. Now, converters. So you need converters here also, because reason is that your solar PV will generate DC power only. If your microgrid is AC, then first you have to convert that DC power into AC power, and then only you can feed to the load. Also, like if you are using a wind as a DER, though wind can generate AC only, but you have to measure whether that AC is having same frequency, means 50 hertz or not. Your voltage is within limits or not. So for that, converters plays a big role there. Next thing is communication system. Like in previous figure, I showed your all the DERs, all the loads, they are connected to the centralized controller. What is meant by connection there? That centralized controller is collecting the data from every generator and every load. How it can connect? When it is connected to them using some communication channel only. That communication channel depends on the geographical area of the microgrid. It may be wireless, it may be wired. Means we can use optical fiber also. We can use some cloud storage also for that. So this is the basic components of the microgrid. So now I explained though already, distributed energy resources what? The generation of electricity by facilities sufficiently smaller. Means this DERs are not that much big that it can match the capacity of the thermal power stations in India. These are very small entities. Okay. And these DERs we can connect at almost any point in the power system. But thing is that we have to control, we have to synchronize these in proper manner. Okay. So I explained this, what is dispatchable source and what is non-dispatchable source. Okay. Dispatchable means what? Your diesel or fuel cell. Non-dispatchable means what? Your wind power, hydropower, or solar. So energy storage system, like I told, just to cope up the unbalance between the generation and demand, we have to utilize some energy storage system. It may be flywheel, it may be hydro. Hydro pump means your pump storage plant. It may be ultra capacitor, super capacitor. It may be batteries or okay. So loads are of, generally we consider loads two type only, critical, non-critical, but we have one more type of load that is called reschedulable load. So critical load means highest priority load. These loads you cannot curtail in any condition, or if sufficient power is not available, then you can curtail this load only in the last. First you have to curtail a non-critical, then only you can come to the critical. So this is the critical load. Then non-critical means lowest priority load within the microgrid. These load may be left unserved in favor of critical load. Means if your power is, you are not generating enough power, then what you can do, you can curtail these type of loads. And another one important thing is reschedulable load. Reschedulable loads means what? These loads are flexible. Means in case of high power demand, you can reschedule these loads to some time instant at which the power demand is not that much high. So these are called reschedulable load. Okay. So additional element I explained already, intelligent circuit breaker. See that point where your microgrid is connected to main grid. If you read the research papers on microgrid, you will read there They call that point as point of common coupling, PCC. But actually this word PCC is used for some other purpose in electric circuit. So that's why according to IEEE standard, that point is called point of interconnection, POI. Then power converter, I told already the purpose, and then communication system. Okay. So see, regarding power converter, one more thing I want to tell. Okay, these days, one term is very famous there everywhere in distribution system, net metering. In net metering, what we are doing, we are installing some solar panels on our rooftop, and if that solar panel is generating some power, if that power, the generated power by the solar PV is more than our local demand, then what we can do, we can sell back this power to the main grid. That concept is called net metering. So like same only, if you are having one converter at the grid, so that what's the purpose of that converter? If you are, your microgrid is generating more power, means initially in definition I told the microgrid can be act as a load for the utility grid or as a source for the utility grid. So if your microgrid is generating more power than its connected load, then in that condition you can sell that power back to the main grid. For that, this converter plays a role there. This converter should be a bidirectional converter, means in case your microgrid is behaving like a load, this converter should flow the power from grid side to microgrid side. And if your microgrid is behaving like a source, then this converter flows the power from microgrid side to main grid side. So this is the main purpose of converters there in microgrid. Okay. So along with advantages of microgrid, we are having some challenges also. What are these challenges? First is bidirectional power flow. If you know, in distribution system, we have only unidirectional power flow, because what? Your power is coming from substation side to distribution transformer to your household. Means substation transformer, then DTR, then household. So the direction of power flow is unidirectional. But in microgrid, sometimes what is happening when your microgrid is behaving as a source, power flow is from microgrid to main grid. But if it is behaving like a load, your micro power flow is from main grid to microgrid. In that condition, in that condition, your protection algorithm should be very much strong, because earlier in distribution system, the protection scheme is your protection scheme is based for unidirectional power flow only. But in microgrid, it should be applicable in both directions. So this is the first problem. Another is stability. Since microgrid, the power generation, we cannot estimate 100% surely. Okay, tomorrow what is the power generation by the wind and solar? Because this depends on many things, your weather forecasting also, and many other environmental factors. So another one is modeling. It is very difficult to model a microgrid which can work 100% securely. See, there are many things like cyber security, other things. So modeling is a task in microgrid itself. Low inertia. See, just like synchronous generator, which are having very high inertia, microgrid is having DERs only, which are having very less inertia. So what can happen if your load is suddenly dipped or load is suddenly increased? Your complete system can be collapsed. So it is having low inertia. And again, uncertainty. Uncertainty in terms of what? In terms of both load also and generation also. We cannot surely tell that, okay, tomorrow what will be the generation of the DER connected to the microgrid. So these are some challenges in the microgrid. So to overcome these challenges, we have to control the microgrid in a proper manner. So what type of control is available? So see what they are telling. Your non-dispatchable source must operate as close to the maximum power as possible. What's the reason? Non-dispatchable means solar or wind. Solar and wind provides generally very less cost power, means the power is very cheaper. So first we try to extract as maximum power from these sources as possible. Then dispatchable sources, they connected to microgrid through inverters. They are controlled by their inverter so that energy can be injected into the grid. Dispatchable means what? Your diesel or fuel cell. Means based on the load condition only, they will regulate their power output. Okay. So see, reference voltage and reference frequency is a very important term in microgrid control, because in grid connected mode, it is okay. You can take the reference voltage and reference frequency from the grid side, and you can regulate your DERs based on that particular frequency voltage. But in standalone mode, in islanded mode, when grid is not available, then to get the voltage and frequency reference is very difficult. So for that, what you have to do, you have to follow some master slave technique. Master slave technique means what? You will choose one stable source of power as a reference. Means that particular source of power you will considered as a reference. It will provide your frequency and voltage, and all other sources will follow this particular master. So this technique is called master slave. Okay. So see, I mentioned there, based on the amount of energy produced by each source and load demand, the reference value for each slave converter is set. So, so microgrid control can be of basically three types: centralized, decentralized, and distributed. But we focused only two: centralized and decentralized. Centralized means what I already explained. Okay, all the data centralized controller will collect and monitor, process the data, and generate the set points for the DERs and load. What is decentralized control? Means your localized control is only there. Local controller are selected, connected to every load and every source, and these local controller, they collect the data and immediately process the data and generate the command for that particular DER only. Means see, centralized controller complete system is observable. So stability is more in centralized controller, but in decentralized controller, that particular localized controller is responsible for the successful operation of this particular DER or load. So decentralized controller is having some stability issue. Okay. So what is hierarchical control strategy? So smart microgrid energy and power management strategy can be realized in different control layers. Means control strategy is having different layers. One is called primary, secondary, and tertiary. Three layers we are having. Let me explain this with some figure, then we will save some time. So see, primary control layer, it will deal with what? Load sharing. Load sharing, how we can share the load on the generators. Like in synchronous generator, we are having some group control method. Same here. Primary layer, what's the purpose? Purpose is to share the load among the available DERs so that your system will be stable. No need to curtail any load. So primary layer is for group control or power sharing. Secondary control. Secondary layer is for what? Voltage and frequency control and synchronization to the main grid. Okay. So purpose of primary control is what? Load sharing. And purpose of secondary control is what? System stability. Similarly, tertiary control is what? Tertiary control is for basically energy management. We are having optimal power flow and market operation. So this is the purpose of control. This control is classified in three layers: primary, secondary, and tertiary. So primary layer actuates just after the any variation in the power demand or voltage variation. Okay. So it starts in milliseconds, and the tertiary layer, it will take some few minutes to perform its purpose. Okay. And localized controller is responsible for primary control. Secondary control can be done by localized controller or centralized controller. Tertiary controller is dealt by primarily by centralized controller. So this is the hierarchical control strategy for a microgrid. So I think this we can skip. Okay. So what is energy management system in a microgrid? Energy management system means what? You are having different loads, means your load demand is varying continuously. Your generation is also varying continuously. But what you have to do, you have to match both load and generation and load without curtailing any critical load. So that is the basic purpose of the microgrid energy management system. So what we are having distributed energy resources. We are having energy storage systems. We are having demand response. Means demand response means what load is connected. That is called demand response. Okay. Then condition of grid, whether you are connected to grid or not connected to grid. Then weather forecast. Why weather forecast? Because weather forecast is very important in case of renewable energy based distributed energy resources. See, don't confuse with then the distributed energy resources. Your DERs can be based on renewable energy or can be based on fossil fuels also. Like a small diesel generator, we can also call a DER, distributed energy resources, but it is based on fossil fuels. And DER we can call a solar PV also. DER we can call a wind also. So these are the basic components when you are doing microgrid EMS. So we will monitor the data from each of this. Then we analyze this data. Then next we forecast this data. Okay, today the condition is that this. After 1 hour, after 2 hours, or after 1 day, what will be the condition there? Based on that, we will optimize the system and we will take some input from energy market also. That what is the tariff condition in the utility grid? Tariff means what? At what price utility grid or main grid providing power to your micro. Ji.
Sir, 2 minutes left only, sir.
Okay, sir, I am binding only.
Yeah, okay, sir. Thank you.
Okay, I am binding. So Then we can do the real-time controller. Means after you monitor this data and analyze the data, forecast the data, you will take input from the grid side also. Then only we can generate the command for your system, means your all the utilities. Okay. So again, microgrid is what? We are forecasting the data from the DER. We are forecasting the data from electrical thermal. What is the load? Their load demand response, what we call. And state of charge of the energy storage system. State of charge of battery means what? Just like your mobile phone, you are having battery in mobile phone. So that percentage, that is only called the state of charge. Then operation limit, security and reliability constraint. There is some operator there in power system. They will only provide you the limits for voltage, frequency and all the things. So based on this, main grid interconnection status and energy price forecasting. Based on this, your microgrid centralized energy management system, it consider your microgrid model, what type of model you are having, and then it will generate the command to your demand side management, means whether you have to switch on, switch off any load, whether you have to partially curtail any load, and it also set the points for DER, means how a DER has to regulate its power output so that the frequency should be stable, or in case of DC, that DC bus voltage should be stable. So this is the particular thing with microgrid energy management system. So I think I have to bind here now. I think maybe things are clear to you. If you have any doubt, you can ask now.
Any doubt, students? Okay, sir. Thank you, sir. Thank you very much, sir, for motivating our
जी
students. I hope student will be benefited. Your practical approach was
okay
very
sir.
nice, sir. I hope
जी जी
electrical department want to thanks to you. In future,
जी sir.
we want cooperation from your side,
जी
sir.
okay sir.
Thank you, sir.
हाँ हाँ okay sure sir sure. जी
Thank
जी
you.
okay okay
थैंक यू
sir.
वेरी मच
जी
प्रशांत
thank
भाई, वेरी नाइस टेस्ट
जी
लेक्चर,
sir okay sir.
है ना. आई एम वेरी
जी
ग्लैड
जी
दैट सच अ नाइस एक्सप्लेनेशन गिवन बाय यू.
जी
और आगे भी कॉपरेशन
okay
मिलेगा
sir.
प्रशांत भाई, ऐसा हम उम्मीद करते हैं.
हाँ
सब
हाँ
लोग
सर बिल्कुल
मतलब
सर, एक्चुअली टाइम बहुत लिमिटेड था ना,
नहीं,
तो
आगे
चीज़ों को
कभी हम
बहुत
ऐसा
ब्रीफ में
होगा और
एक्सप्लेन
कभी
किया
होगा
था.
तो